In this question, a platform is pulled with horizontal acceleration A. A particle is projected from the platform at an angle theta with the horizontal with respect to the platform as shown. The value of tan theta such that the particle again comes to the starting point on the platform is. Dear student, the motion of the particle from the trolley will be such that the final displacement in the y direction will be 0. We can write down from the equation of motion that u sine theta t minus half gt square, that is third equation of motion in the vertical direction, this should be equal to 0. Hence the time should be equal to 2u sine theta by g. Now in the x direction, it is given that the particle comes to rest from the starting point on the platform. So with respect to the platform, the x displacement will be 0 as well. So we can write down that u cos theta t minus half at square, this should be equal to 0. A is the acceleration of the platform and the relative acceleration of the particle in the x direction will be equal to a as well. From this we can write down that t will be equal to 2u cos theta by a. Now these two should be equal, so we can write down that 2u sin theta by g will be equal to 2u cos theta by a, giving a value that tan theta should be equal to g by a equal to 2. And hence for this question the correct answer, dear student, should be option number 3. Now let us move to the question number 37. Question 37 says a vertical height of the projectile at time t is given by, so y is given to be equal to 4t minus 5t square. The horizontal distance covered is given by x is equal to 3t. You have to find out the angle of projection with the horizontal. Dear students, we can write down that the vertical displacement is actually equal to u sin theta t minus half gt square, and the horizontal displacement is u cos theta t. From comparing, we can write down that u sin theta is equal to 4 and u cos theta is equal to 3. Meaning that tan theta, if we divide these two equations, comes out to be equal to 4 by 3, or theta will be equal to tan inverse 4 by 3, giving us that the correct answer for this question is option number 3. I hope you understood the solution. Let us move to the next question. Question 38 says calculate the time of fall of a body which covers 7 by 16 of total height of the tower in last second of its fall. Assume that the body is released from top of the tower. Now dear students, in this question number 38, it can be easily solved if we write down that the formula for the time of flight of falling from initial zero velocity is under root 2h by g. Now it is given that in last second of its fall, the distance traveled will be equal to 9 by 16, that is 1 minus 7 by 16 times the total height. As 7 by 16 is done in the last second, so in remaining t minus 1 it will be 1 minus 7 by 16. So this will be equal to under root of 2 9 by 16 h by g. So this we can write down that t by t minus 1 will be equal to 4 divided by 3, that we have divided first and second equation, and from this we can write down that t will be equal to 4 seconds, giving that the correct answer for this question is option number 2. Now let us move to the question number 39. In question 39, two balls are projected from 2 points in vertical plane as shown. AB is a straight vertical line. It is given that the balls collide in air if V1 by V2 is equal to. The student, the ball will collide if their horizontal displacement at a certain instant of time is same. The horizontal displacement will be same if the horizontal velocities are same, that is V1 cos theta 1 will be equal to V2 cos theta 2. From this we can write down that V1 by V2 will be equal to cos theta 2 by cos theta 1. You can see that among the given options that the correct answer should be option number 4. Now let us move to the question number 40. In question 40, the equation of trajectory of a projectile is given by y is equal to minus x square plus 10x, where x and y are in meter and x is along the horizontal and y in vertical upward direction. The particle is projected from origin. So we have to find out the option which is incorrect. It is related to initial velocity, the horizontal range, the maximum height and the angle of projection. Dear student, the equation of trajectory can be written as y is equal to x tan theta minus gx square by 2u square sec square theta. On comparing, we can write down that tan theta will be equal to 10 or sin theta will be equal to 10 divided by root of 10 square plus 1. So this will be 10 by root of 101. On further comparing, we can also write down that g sec square theta by u square 2 will be equal to 1, giving us a value of u to be equal to g sec square theta by 2. That will be equal to root of 505. Height can be written as u square sine square theta by 2g, and on substituting the values this will be 25 meter, while the range will be equal to u square sine 2 theta by g, and on substituting the values this will be equal to 10 meters. The student, as we see that the incorrect option among the given option is option number 4, as the angle of projection is tan inverse 10, and hence for this question the correct answer is option number 4. Now let us move to the next question.